Hello class, and hope everybody's having a good day. Today we're going to take a look at lesson 3.2a, maximum and minimum values. So from our warm-up it says determine the vertex of f at x equals -3 bracket x minus 1 bracket x plus 3. Now first of all, what do we need to remember? What form this is in, folks? This is in factored form. And what do we know from factored form? We already know that our x-intercepts are the opposite of what you see in your bracket, 1 and -3. So if I have a graph, ladies and gentlemen, I already know I can plot 1 and -3 as my x-intercepts. Okay, from that, ladies and gentlemen, there's a shortcut way to getting to the vertex, and that's by getting the axis of symmetry first and then subbing that value into the function. So the axis of symmetry, if I change colors here, is going to be x equals r plus s divided by 2. So it's going to be 1 subtract 3 divided by 2. That's -2 divided by 2, which equals -1. So x equals -1 is our axis of symmetry. Let's check our graph. Hey, that looks very good because guess what, ladies and gentlemen? It is equal distance between our two symmetry points, which are our roots, which is -3 and 1. Once we have that, ladies and gentlemen, we can sub that in to the function. So instead of f at x, we're going to go f at -1. So wherever we see an x, we're going to replace it with -1. And then we can find our y coordinate of our vertex. So subbing that in, simplify quickly, and we get that our y value, or y, or f at 1, equals 12. So what does that tell us, folks? So therefore, our vertex is -1 and 12. So we can start by plotting that. Okay, so we're going to start with -1 and 12, and taking a look, ladies and gentlemen, the vertex has to be on the axis of symmetry, so far that's pretty good. And then you may want to double check by using the step pattern. So remember, the step is a times 1, 3, 5. Our a in this case is -3. Looks like a good direction of opening down. Okay, so what's our step pattern going to be? It's going to equal -3, -9, and -15. Now the -15 may not fit on, but let's take a look. So from here, from your vertex, you go over 1, down 3, over 1, down 9. Other direction, over 1, down 3, and down 9. Okay, so it's more narrow because it is a vertical stretch by a factor of 3. And again, you write down your expression, f at x equals -3, x minus 1 times x plus 3. Again, that's our warm-ups. If you need any help with that, let me know. All right, today's lesson, ladies and gentlemen, is 3.2a, maximum and minimum values. Just remember, that's called the optimal value. All right, good. Taking a look at a quadratic function, if a is greater than 0, the parabola opens up. Okay, and that means what do we have at the bottom? A minimum or maximum? We have a minimum value. Whereas if a is less than 0 or negative, that means it opens down. And if it opens down at our vertex, we have a maximum value. All right. Okay, and just remember, folks, that the min or maximum value, again, that could also be used optimal value, could be substituted in there, is the y value of the vertex. Okay, let's take a look at an example here. It says to determine the min or max value. Just remember, guys, as a hint, it may be easier to factor. Okay, so factor and find vertex. That's going to be easier. Okay, if you can't do that, then complete the square. So if it's hard, i.e. the factoring's not going easily, then complete the square. All right. Okay, let's take a look at our first function here, ladies and gentlemen. So, f at x equals x squared minus x squared plus 12. That looks like a simple factor. Again, if you need to do your product equaling 12, your sum equaling -8. What two factors do we have? -2 times -6. So again, f at x equals x minus 2 and x minus 6. So what does that mean? Our zeros are the opposite of what's in the bracket. So our zeros are 2 and 6. Once you know your factors, sub it into the axis of symmetry. So x equals r plus s divided by 2, which equals 2 plus 6 divided by 2, which equals 8 divided by 2. So x equals 4. That's our axis of symmetry, but it's also the x-coordinate of our vertex. So you're going to sub that function, that value into the function. So wherever you see an x, you're going to replace it with a 4. Sorry, my fault. So it's going to be 4 squared minus 8 times 4 plus 12. So simplify that in your calculator. You got 16 minus 32 plus 12 should give you -4. So what does that tell us? So therefore our vertex is 4 and -4. And remember, when you're looking for your minimum or maximum value, your optimal value here is -4. But we need to decide if it's a minimum or a maximum. So we look at A. Is A greater than 1? Yes, it is. So it opens up. That means we have a minimum, because it opens up. So we have a minimum value of -4. All right, and again, that's an example where it's easy to factor and you can get your minimum values. All right, example 2. Taking a look at this, ladies and gentlemen, if I was to try to do my factoring, I would say product equals 6, which is, remember, -2 times -3, A times C. Okay. And then my sum equaling 12. Right away, I notice there's something fishy about this. Okay, I can't factor because I'm not going to get even numbers. So with this, so what I'm going to do is therefore complete the square. Okay, so taking a look at completing the square, we're going to use our practice from last class. So again, you factor A out of the first two terms. So it's going to be x squared minus 6x minus 3. Okay, move that up. Now to get B divided by 2, that equals -6 divided by 2, which equals -3. Then you take -3, guys, and you square it, so it's 9. That's the number we're going to add and subtract inside our bracket. It's going to be +9 and subtract 9. Okay, and remember, folks, from last lesson or last couple lessons that we only need the first 3. Okay. So I'm going to complete the first 3. I'm going to do it in a little combined step. So it's going to be x minus 3 squared. Don't forget that this -9 needs to come out. So -9 times -2 is +18 minus 3. And to finish off, put it into finally get into vertex form. So basically, guys, folks, your vertex is going to be 3 and 15. And again, to decide your min and max value, it is your y value of your coordinate. And then you have to look at A. And in this case, A is negative, so it opens down. That means you have a maximum. So therefore, you have a maximum of 15. Okay, so put down here that it opens down. That tells us we have a maximum. All right, any questions with that, folks? All right, so what I want you to try to do, ladies and gentlemen, is for the next homework, I would like you to determine the min-max value. So try these next ones. So determine min-max values. Okay, and then try doing your textbook questions. I will just quickly put the answers to D, E, and F and G here just so that you have them, but please try them yourself to make sure you can get it. Okay. If you have any questions with these, please come and see me. And I hope you guys have a great day as I'm writing these out. Again, if you need some help, please come and see me, guys. All right. Here ends our lesson 3.2a, and have a fabulous day.